All right, so let's actually use this on some applications. Some of your favorite things to do are word problems. So to go forward, there's just two new vocabulary terms. One is, let me go ahead and just change my color, angle of elevation. So what that means is when you are standing, you draw horizontal from the eye line, and your angle of elevation is you looking up, and it creates this angle. So that's pretty intuitive, I think. Angle of elevation, elevation is going up. Another term for that is angle of inclination. So angle of depression is just a bit different. Again, you draw the horizontal from your eye line, and your angle of depression is the angle looking down. So really, it's creating this right triangle, where this one creates a triangle, I guess, upside right, if I want to say it that way. So often, students make the mistake of putting the angle of depression right here, and that will not give you the correct answer at all. Okay, so angle of depression has to create a triangle, and lack of a better way to say it, upside down in a way, where angle of elevation creates this triangle. And your angle goes here, and angle of depression goes here. So really important. All right, so your next example says, suppose that you're headed toward a plateau 50 meters high. If the angle of elevation, so I'm looking up, to the top of the plateau is 20 degrees, how far are you from the base of the plateau? So here's your plateau. Here is your angle of, remember you draw that horizontal, angle of elevation. So your angle goes here, so that was 20 degrees. And then we know that the height is 50 meters. So typically height is always this line, which is known to be the perpendicular line. Okay, so it makes the right angle. That's how we measure height, is it has to make a right angle. And we want to know how far we are from the base of the plateau. So ask yourself, are you looking for a side length or an angle? We're looking for a side length. So that means we're going to be using sine, cosine, or tangent. If we were looking for an angle, we'd be using the inverse functions. So I'm standing here, 220 degrees. I have my adjacent and my opposite. So that's why it will be tangent of 20 degrees equals opposite over adjacent. Now hopefully you feel comfortable solving for this, so we're going to get x times tangent of 20 degrees equals 50 divided by tangent of 20 degrees. So x gives me 50 divided by tangent of 20 degrees. I have to rely on my calculator. And I'm going to do 50 divided by tangent of 20. And I get about 137.37 meters. So the key thing in mathematics is if you're given an application, a word problem, you need to give the answer in a full sentence. So I would say, I am about, since I rounded, 137.37 meters away from the base of the plateau. Okay, so our very last example is one more new vocabulary term and then putting it to use. So we're going to discuss bearing. And bearing shows up in this unit, and then it shows up again at the end of the term. So tuck it away in your memory. We use this with navigation and surveying. So, airport control towers use this, ships, and so forth. All right, so bearing the definition is it's attached to the north and south lines always, okay? So when you are talking about bearing, it's always in relation to the north and south. It will only form an acute angle. So acute, remember, is less than 90 degrees. And it will either be heading east or west. So for example, if I'm focusing here on this 30 degrees, how I read this is, well, it's attached to the north line, so that's why I mentioned north first. But then it's headed towards the east, and so that's why I mentioned east last. And how I would say this is 30 degrees east of, let me actually just capitalize east of north. All right, so let's give this one a shot. So this one, if I wanted to write it out, or say it out loud, I should say, this would be 20 degrees. Ask yourself, is it heading east or west of the line? East of, and it's attached to the south. Now, if I abbreviate this, that would be S 20 degrees east. All right, so like this one, just going to say it out loud. That is saying that's 50 degrees west of south. And this one is 70 degrees west of north. Okay, so notice the very first letter you mention is either north or south, because that's what it's always attached to, and then what the degree is, and then where you're heading. So your last example, we're going to talk about a Boeing 777 aircraft takes off from O'Hare Airport on runway 2 left, which has a bearing of, that says 20 degrees east of north. So this one's really nice because it gives you a diagram. Some of them don't, so you'll have to come up with what it looks like. After flying for 1 mile, so here's this aircraft, I fly for 1 mile. I'm granted, the pilot, I guess I'm not the pilot, the pilot is granted permission to turn exactly 90 degrees and head to the northwest. After the plane goes 2 miles in this direction, what bearing should the control tower use? So the fact that it's saying what bearing, that means we have to tell our answer will be whatever's attached to our north or south line. So our answer, let's see if I can make it stand out, will be this little angle right there. But I think I'm going to be forced to find this entire angle first. So if I'm looking at that, I'm going to just erase this so it gets a little more clear. If I'm looking at this entire angle, I'm looking for an angle. So ask yourself, do you use tangent, sine, or cosine, or do you use the inverse functions? Well, if I'm looking for an angle, I want to use the inverse functions. Well, I'm given the 1 and the 2. Well, 1 is adjacent to the angle and 2 is opposite. So that is why I'm forced to use tangent, and it's the inverse. And your ratio is opposite over adjacent. So going here to my Desmos, inverse tangent of 2 divided by 1. And I get about 63 43, 43 degrees. However, that's that entire angle. I just want the bearing. So I just want this leftover piece. So that means I want to take away that 20 degrees. All right, so your final answer. So that's an acute angle, so it's meeting the definition of bearing. Ask yourself, is it attached to the north or the south line? Well, visually I can see it's the north. And then ask yourself, is it heading towards the west or the east? And I can see it's heading west. So that is why the control tower should use a bearing of 43.43 degrees west of north. All right. Have fun doing homework. Reach out if you have any questions at all.